The next thing I'd like to discuss are string methods, which, similar to list methods, are functions that specifically apply to the string variable that we are using. And in order to access these methods, we use the following syntax. The name of our string variable, followed by a dot, the name of the method that we'll be calling, and the arguments needed by that method in order for that method to be executed properly. Just for some examples of common things that we often like to do with strings, we often want to count the number of occurrences of a particular substring within a string. We may also wish to find the location index-wise of the occurrence of a particular substring within a string. So you can imagine that if we're counting the occurrences of something and we know that they occur every so often, we may wish to then find where they do occur so we can extract them perhaps. Another thing we often do with strings is want to know what type of keys were entered when the user was entering in that information. For example, did they only give us alphabetical keys, letters in some combination, uppercase or lowercase? If we wanted the user to enter a number, but we read it in as a string, can we check to see if the string that was entered contains only numerical values? Things of that nature. And so there are string methods that will accomplish and check this for us. We occasionally want to take a string once we know what types of values it contains and convert it, quote unquote, more on that later, to either all uppercase or all lowercase values in order to normalize the type of alphabetical values occurring in that string. And last but not least, we may want to split a string into individual words for some more advanced analysis, or to switch from indexing according to each character to counting where a word occurs as we would naturally see words. And of course, there are many, many more string methods, but these are some of the most common ones and the ones that we'll do some examples with. As a running example, I would like to think about the tweet that we have here from the thoughts of dog as being held in the contents of the string variable good dog. Implementing some of those first methods mentioned on the previous slide, we may want to count the number of times that the letter I occurs in this string. If I were to call the count method with this argument on good dog, it is going to give us an output of 6. Let's highlight where those 6 occurrences of this string are occurring. The first I that we see in the text is this I right here, but this is an uppercase I, so this is not being counted when we implement this count function, because here I have a lowercase I. So we scan through the all capital letters, and the first lowercase I we see is right here. We continue on and notice that there is an I right here in the word did. Because I did not put a space before this I and a space after this I am not forcing the count function to find the I by itself, and any occurrence of the lowercase I will be counted. So indeed, this I that occurs in the middle of the word did is being counted by this count function. So that's 2. There's an I in circles for 3, an I in is, and an I right here, and those all together make the 6 counts of this letter I occurring within the good dog variable. Another thing I might want to do is find the occurrences of a specific word. So if I call the find method on the string good dog, and I pass in the argument car, what's going to happen is we are going to search the good dog string until we find the first substring car. And what will be returned by this method is the index counting from the start of the string of where this word first begins. And that's even if it were to occur many times. Counting from the left side into this position right here, remembering to start counting at 0 and count when we see a space, we begin the word car in the 15th position, in this fairly long string. Now imagine that we were to call the .find function with the word bus, which does not occur in this tweet. Our .find function needs to return something to us, but it needs to return something to us that obviously indicates that this word was not found. In order to do that, the find method prints a value of -1 when it cannot find the occurrence of this particular substring. And this -1 value is going to serve to us as what's called a flag that this find function did not find this particular substring. Now when we called the .find method on CAR in all capital letters, that particular substring only occurred once in this large string. However, a more common word like the word to appears more than once within this string, and the .find method is going to return not all occurrences of the substring, simply the first occurrence of the substring when viewed left to right. Sometimes that can be particularly annoying when you're trying to find the absolute last occurrence of a particular substring within a long bit of text, and for that reason there's a reverse find method that we simply call rfind. What this method will do is start at the end of the string and work its way back until it finds that occurrence, and then it will return to us the index of this particular string as viewed from the beginning. So it's a way of finding the very last occurrence of a substring within a larger string. Now recall something that's been said a few times in these videos, which is that strings are immutable objects. So another method that we commonly use is something like lower, which when called by a particular string returns the exact same string, but with absolutely every letter a lowercase letter. All other values that occur in the string, like spaces and punctuation and numerical values, will stay precisely as they are, but any uppercase letter will be converted to a lowercase letter. So when we ask Python to print the good dog string with the .lower method applied to it, we see the output on the top right over here. However, strings are immutable, and so the .lower method does not actually change the good dog string. It simply prints what the output would be. In other words, it does not make the change permanent, but just shows you what the change would be. This is demonstrated by asking the computer to print good dog. After calling the .lower method on the good dog string, we get back our original good dog string with the capitalization. So if we truly wanted to change the good dog string to be with all lowercase values, we would have to reassign the value of the good dog variable to be the contents of the good dog .lower method as follows. For a little bit of a more advanced example, let's see the types of manipulations we can do if we want to do some uniform formatting on the good dog string. As we've seen, we can call the .lower method on the good dog function to obtain this output right here. Let's save that output into a new variable called small dog. In the next 2 lines, I have to employ a little bit of some more advanced syntax that you don't need to worry about right now, but what I can do is walk through my new small dog variable and exchange all periods for spaces. And I can save the result of that in another new variable that I'm now going to call clean dog. And if I ask Python to print the clean dog variable, it prints all lowercase letters and absolutely no punctuation. If I then call the split method on the clean dog variable, what it does is separates the string by all the spaces that it sees. This has the effect of breaking apart one long string into individual words. So the variable that I've called split dog here is not actually a string. but rather a list of strings. As you can see when I print the split dog list, because it puts those square brackets here and here, and it puts the quotations around the words. This could be incredibly convenient to me as I think back on using that counts option on the letter I. There were a couple of issues with .count and .find when I simply passed in the letter I, such as it would find the letter I in the middle of a word and it wouldn't recognize a capital letter I. Doing this type of formatting on your string solves the capitalization problem and solves the middle of a word problem. And so if I did this type of formatting on my string initially and then went through my list and asked for the index of just the letter I, I'm going to find the first occurrence of the word I when it appears in my long string, no matter if that I was a capital or a lowercase I. And that can be really useful when you're trying to search text and eliminate all of the rules of English to just find particular occurrences of a word, which is the thing that comes up in computer programming a lot.